In this video, we're going to learn how to verify trigonometric identities. So before you learn how to verify trigonometric identities, there are some important relationships between sine, cosines, and tangents that you need to know. One of them is sine square x plus cos square x equals 1. Okay, so this is often referred to as the fundamental identity, and then from this one you can derive 1 plus tan square x equals to sec square x. Okay, and then you also have 1 plus cos square x equal to cosec square x. Okay, so we also know that tan x equals to sine x over cosine x, and then cot x equals to 1 over tan x, which is also equal to cos x over sine x. Okay, so cosec x is equal to 1 over sine x, and then sec x equal to 1 over cos x. Okay, so you need to write this, you need to know these relationships to solve problems that are related to trigonometric identities or verifying trigonometric identities. Okay, so we have a trigonometric identities here. So we are asked to verify that this part is equal to this part, or this part is equal to this part. So I used to solve this kind of problems in the following step. So anytime you are given a problem in this form, the first step you want to take is to pick a side. Okay, so I can choose to pick the left side and prove that it is equal to the right side, or I can choose to pick the right side and prove that it's equal to the left side. Okay, so personally I pick the left side when solving problems like this. Okay, so after picking the left side, the second step is to convert every term you have there to sine or cos. Okay, and the third step is to simplify. So for here now, all our terms are in sine or cos, so we move to the third step, which is simplify. So we have sine square is also equal to sine times sine x. Okay, so divided by cos x, and then this is equal to tan x sine x. Okay, so we know that sine x can also be equal to, this can also be equal to sine x times sine x over cos x. Okay, equal to tan x sine x. Okay, so from our relationship we know that tan x equal to sine x over cos x. Okay, so that this becomes sine x over cos x, replace it with tan x. Okay, so this becomes tan x times sine x, which is equal to tan x sine x. So we've proven this part. Okay, so this means that these two identities are equal to each other. So let's take another example. So for example 2, we have cos theta minus sine theta. Okay, so this squared Okay, so this over cos theta. So we have to verify that it's equal to sec theta minus 2 sine theta. So like we did before, we have to pick a side. Okay, so we are going to be picking the left side. Okay, so the next step is to convert everything to sine or cos. So everything here is already in sine or cos. So we have minus this theta. Okay, so the next step is to expand, simplify this term here. Okay, so if we don't want to write this again, we just need to put this symbol here. Okay, so this means that this term is repeating itself. Okay, so we have to expand the brackets from here. So expanding the brackets, we have cos theta minus sine theta. Okay, close brackets, cos theta minus sine theta divided by cos theta. Okay, so we have to expand the brackets of these numerators. Okay, so this is cos theta times cos theta is cos square theta minus sine theta cos theta is minus sine theta cos theta minus sine theta times minus sine theta is plus sine square theta. Okay, so this is divided by cos theta. Okay, so what we have now is equal to, now we can pick sine square theta and cos square theta together, so that we have cos square theta plus sine square theta, okay, minus sine theta 2 sine theta cos theta. This happens twice, sorry, it's a mistake in the analysis. So this happened twice, cos theta sine theta. Okay, so this is divided by cos theta. Okay, so cos square theta, we know that cos square theta plus sine square theta equals to 1. So we are going to replace this part with 1. Okay, so this is now equal to 1 minus 2 sine theta cos theta. Okay, so divided by cos theta. Okay, so we can pick the individual numerator terms and divide them by the denominator. So this would look like 1 over cos theta minus 2 sine theta cos theta divided by cos theta. Okay, so we have from here we knew that 1 over cos theta equals to sec theta. Okay, so and we knew that cos theta can cancel out cos theta from here, so this should be equal to sec theta minus 2 sine theta. So we've shown that this part of the equation equals to this part of the equation. Therefore, we verified our trigonometric identities. Let's take another example. So let's say cosec theta sec theta over cot theta equals to, or is equivalent to 1 plus tan square theta. Okay, so you can pause the video and try to work this one out yourself. Okay, so like we did before, we pick a side. So I'll be picking the left hand side. Okay, so I'll be converting everything to sines and cosines. So cosec theta is 1 over sine theta, and then sec theta is 1 over cos theta. Okay, so this is divided by tan theta cos theta, so this is cos theta over sine theta. Okay, so I'll be solving for just the left hand side mostly. Okay, so this one multiplied by this, we should have equal to 1 over sine theta cos theta. Okay, so this is divided by cos theta over sine theta. Okay, so to change this division sign, we can multiply. To change this division sign to multiplication, we have to switch the denominator of this fraction and the numerator of this fraction. Okay, so this becomes equal to 1 over sine theta cos theta times sine theta over cos theta. Okay, so sine theta will cancel out sine theta, so this is ultimately equal to 1 over cos square theta. Okay, so 1 over cos square theta is still equal to sec square theta, because sec equal to 1 over cos theta. Okay, so from our trigonometric identities, relationship between our trigonometric identities, we know that 1 plus tan square theta equal to sec square theta. Okay, so sec square theta can still be replaced with 1 plus tan square theta, so this part becomes equal to 1 plus tan square theta. Okay, let's take another example. So for our last example, we have number 4. We have cosec square theta minus cosec theta. So you have to verify whether this is equal to cot square theta over 1 plus sine square theta over 1 plus sine theta, not sine square theta, sine theta. Okay, so you can pause the video and try this one out yourself. Okay, so like before, we pick a side, so I'm going to be picking my left hand side. Okay, and I'm going to be converting it to my right hand side. So cosec theta, we know that cosec equal to 1 over sine. Okay, so cosec theta squared is still the same thing as 1 over sine square theta minus 1 over sine theta. Okay, so for this left hand side, okay, so we can simplify this further, okay, by taking the LCM of the two fractions here. So the LCM of these two fractions is sine square theta. Okay, so this is divided by sine square theta divided by sine square theta is 1 times 1. So we have 1 minus sine square theta divided by sine theta is sine times 1. So we have sine theta. Okay, so this is it. Okay, so if we look further, we cannot easily break this fraction down again, and if we try to break it down again, we'd probably go back to the beginning part. Okay, so there's a step that you can use. We know that if we multiply 1 plus sine theta over 1 plus sine theta, if we divide both of this by themselves, they equal 1. So multiplying it by the numerator and the denominator is still the same thing. The reason why we're using 1 plus sine theta is because of this term here. We had 1 minus sine theta, so we needed a conjugate term, that's an opposite term that will make this difference of 2 squared. Okay, so that will make it kind of like 1 minus sine square theta. Okay, so that's why we introduced the conjugate term here. So we are using the conjugate term to multiply the numerator and the denominator. Okay, so if you do that, you have 1 times 1 is 1 minus sine theta plus sine theta, okay, minus sine theta times sine theta squared. So this is sine theta squared. Okay, so this is divided by sine square theta, okay, open brackets 1 plus sine theta. Okay, so this is now equal to 1 minus sine square theta, okay, divided by sine square theta. Okay, sine square theta over 1 plus sine theta. Okay, so if we look at this term, it is still simplifiable. So we also know that sine square theta plus cos square theta equals to 1, right? Equals to 1. So this means, this implies that cos, if you subtract sine square theta from both sides, minus sine square theta minus sine square theta. Okay, so this would be cos square theta equal to 1 minus sine square theta. So we basically replace 1 minus sine square theta with cos square theta. Okay, so this would look like, say, if you carry this fraction up here, it becomes cos square theta over sine square theta. Okay, so open brackets 1 plus sine theta. Okay, so we know that cot theta equals to cos theta over sine theta. Okay, technically we'll just be replacing cos theta over sine theta here, so this becomes cot theta, and then there's a square, okay, times 1 over 1 plus sine theta. Okay, so this is now equal to cot square theta divided by 1 plus sine theta. So we verified that this left part of the equation is equal to the right part of the equation. Okay, so thanks for watching this video. If you liked it, leave a like button, share with your friends, and subscribe to the channel. Thanks for watching.